So the next series of videos will deal with different what they call classes of compounds. What classes of compounds are in organic chemistry is these are not hydrocarbons. So a class of compounds has hydrogen and carbon and something else. And that something else is called the functional group. So in this video we're going to deal with one class of compounds called the halides or halocarbons. These compounds contain hydrogen and carbon just like all organic molecules, but they also contain iodine, chlorine, bromine, or fluorine, or some combination thereof. And for this reason, they're called halocarbons. Now, every one of these things has a use, and we're going to talk about, in many cases, how they are actually made and how they are useful. So, for example, the classic example of a halocarbon is a CFC, or a chlorofluorocarbons. These were used as refrigerants, and what that meant is they were inside your refrigerator or your air conditioner. They don't use them anymore because they destroy the ozone layer, but they use similar molecules even today. And the way this works is, the way your refrigerator air conditioner works, to make it really fast, is you have a gas that's trapped inside some tubes, essentially, and you have a pump. There's not a lot of moving parts for an air conditioner or a refrigerator. Okay, and so what essentially happens is inside your refrigerator, where it's cold, in the walls you have liquid CFCs turning into gases, and when they do this, they absorb heat. Okay, remember, when you absorb heat during this process of a phase change, your temperature, it's not like things are heating up. What's literally happening is heat is being removed from the interior refrigerator, okay, and being absorbed as the liquid turns into the gas CFC. And then the compressor compresses the gas back into a liquid. That's a little pump that you have in your refrigerator air conditioner, or the thing that makes the noise that you hear. And what that does is it turns the gas back into liquid. When the gas turns back into liquid, the heat is released. However, it's designed by the engineer so that the heat is released in the back of the fridge. So if you ever touch the back of the fridge or feel the bottom of the fridge, it will feel pretty hot, because all the heat that's being absorbed inside the refrigerator is being released outside the refrigerator, and that's how all air conditioners work. That's why cars sometimes overheat when you use the air conditioner in the summertime, and that's why if you've ever been around the back end of an air conditioner, it feels pretty hot on the other side, because the heat that's being removed has to go somewhere and it goes outside. Now, how do we name halocarbons? Well, let's look at the example, and that's going to really guide us when we're using this table. All right? There's a 2 here, and then you see the chloro, and then you see the propane. So I'm going to start with the tree trunk again. The propane is the tree trunk. So I'm going to draw 3 carbons. 1, 2, 3, because that's is the prefix. I didn't put the table on here again, but you might want to have that in front of you. Okay? And now what I'm going to do is I'm going to attach the chloro to the second carbon. So I number my carbons just like I did before. And what this tells me is there's a chlorine in the position off of the second carbon. So the number tells you the location of the special thingy, which in this case is a chlorine, okay, on the propane. So 1, 2, 3, I'll put the chlorine here in the second one, and then I'm going to put all the little hydrogens around it like so. All right. And I'm going to put my 8 dots here, my 6 dots plus the dash, and also one more H here. And that would be 2-chloropropane. Now I'm going to do a couple examples on the next page. Note the prefixes. Fluorine becomes fluoro, chlorine becomes chloro, bromine becomes bromo, and iodine becomes iodo. Iodo. He is the brother of Frodo Baggins. That's a Lord of the Rings joke. Iodo Baggins. Next. All right, so here we go. I'm going to change this one here because this is the one we just did. Actually, I'll just leave it there and we'll do a different one. So this is 2-chloropropane. So what will we name this? Well, this has got 3 carbons again, so it's going to be a propane. But the chlorine is not on the second carbon. 1, 2, 3. Now I could call this 3-chloro or 1-chloro, but the same idea. I want it on the lowest number. So given the choice between naming this 1-chloropropane and 3-chloropropane, I'm going to call this 1-chloropropane. If, let's say, let me just have a little fun with this. Let's say if I were to make this a little longer and change this and put another carbon here, how would it be named now? Well, I would change, now the chlorine is on the second carbon, so I'd be like, okay, it's a 2, draw, put a 2 in there. It's now 2-chloro, but it's got 4 carbons, so now that's going to be 2-chlorobutane. All right? Now, These two are isomers of each other, the next two that I'm going to do. And each of them has a 5 carbon. So each of these guys is a pentane. So there's a pentane here, and there's another pentane here. And each of them has 2 bromos. All right? And we're going to number the carbons again. Now again, we choose the lowest number of carbons. So I can start with the carbon number 1 at this end, or I could do the other end. But this puts my bromines on the 2nd and the 3rd carbon. So I'm going to go that way. And the same thing over here. Now these two compounds are isomers of each other. They're not going to have the exact same name. Okay, but they're pretty darn close. Now, each of them has 2 bromines, so we're going to use a prefix on the prefix, right? So we're going to do the bromo thing, right? But before we can say where the bromines are, we have to indicate that there's not one of them, there's 2. So watch how I do this. Since there's 1 on the 2nd carbon, 1 on the 3rd, but it's just like naming alkanes, there's going to be 2, 3 dibromopentane. So there's a bromine on the 2nd position and 3rd position, and there's 2 of them on a 5 carbon molecule. The next one is also going to be a dibromo, but the difference is going to be in the numbering, right? Because they're both on the 2nd carbon, it's going to be, let me rewrite this because it's squished, it's going to be 2, 2 dibromopentane. Now these are isomers of each other. They have the same molecular formula, they have the same number of carbons, hydrogens, and bromines, but because the bromines are in different positions, they have slightly different chemical and physical properties. Let's name 2 more of these really quickly. Okay, I'm going to throw an extra carbon here. Okay, 2 more actually, to make it more interesting. And let's talk about this one right here. This would just be called iodomethane. Now notice, I'm not putting a number here for a reason, because the iodine here, okay, there's only 1 carbon, so there's no point. If I do this, you won't lose points, but you don't need the 1 because there's no other carbons to put the iodine on. All right, I'm going to do a little erasing to give myself a little more space here to name this last one here. Okay, so let's name this last one. We've got a long chain that's got 7 carbons, so for those who don't remember this, hep is the prefix, so this is going to be a heptane. And then we have 2 iodines, 1 here and 1 here, and so it's going to be a diiodo. I know. Diiodo. It's weird, right? Okay, and now I'm going to number them, and it's going to be 2, 2. 2, diodoheptane. All right, now what if they give you the names? Can you write them? 1, 2 dibromopentane. So how do I do this? I do 5 carbons in a row, 1, 2, 3, 4, 5, and then I put the bromines on the positions. Now I can choose the number of this 1 and this 2, and if I do, I'm going to put 1 bromine here and 1 bromine here, put my 6 dots around each of these bad boys, all right? And then put dash, 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 and on each of those dashes there would be a hydrogen, and that's 1, 2 dibromopentane. If I had to do dichloromethane, methane only has, okay, 1 carbon, okay? And so I'm going to have 2 chlorines on there, and I notice I don't have to number them because it really doesn't matter. I'm going to have 2 chlorines on there, and since carbon always makes 4 bonds, there'll be a dash here, and an H here, and that's dichloromethane. If it was trichloromethane, there'd be 3 chlorines on there. If it was something else like a propane, I'd have to number the positions of the chlorines. Now, how are halides or halocarbons made? Well, they're made in 2 different types of reactions, and I'd like you to actually know these and understand how to recognize them, so you'll see this in the Castle Learning Assignment. Okay, there are addition reactions and substitution reactions, all right? Now, both of these reactions is going to produce a halocarbon. It's going to be, in the addition reaction, you are going to react either an alkene, I did the erase, sorry about that, either an alkene or an alkyne with a halogen as an element. Now remember, as elements, these guys are always Brinkelhoffs, right? So it's Cl2, Br2, I2, or F2. Now, in an addition reaction, what essentially happens is you can predict where the halocarbon is going to go. Addition reactions involve basically unsaturated, okay, hydrocarbons reacting, okay, with a halide. So this is going to be unsaturated hydrocarbon reacting with a halogen. So what's going to happen here? Well, in the presence of an acid, the double bond gets really weak here, and what happens is the chlorines, okay, essentially attach to the carbons adjacent to the double bond. I'll say that again fully. They attach to the carbons adjacent to the double or the triple bond. right? So you can, in an addition reaction, you only have one thing as a product. Essentially, you're adding each of those chlorines to the two carbons around the double bond. The double bond breaks. Remember, one of those bonds is just a pair of electrons. So essentially, you get the 5-carbon chain like this, like you had before, and on the, I'm sorry, it was a 6-carbon chain, my bad. Okay, between the third and the fourth carbon, like right in this spot right here, the double bond breaks, and one of those dots from the extra bond goes there, and then the two chlorines come in here into this position. I'm going to erase my arrow, and I'm going to put right, and then remember the chlorine had 7 valence electrons to start with, so that makes the bond right there, because a pair of electrons bond. So I'm going to erase that now, make that a dash. All right. And what ends up happening in these addition reactions is the chlorines get added to the carbons, okay, and they go on the carbons that are adjacent to, that means next to the double bond and triple bond. So you can predict where the chlorines are going to go. Remember, in an addition reaction, it deals with an unsaturated hydrocarbon. You should be able to recognize them because, like, it's C6H12 versus 14 or something like that. So if you see an unsaturated hydrocarbon reacting with a halogen, you know exactly what is going to happen. And then you get two, I'm sorry, the name of this thing would be, this is 1, 2, 3. This would be 3,4 dichlorohexane. So it goes from being an ene to an ane. Now, the other type of reaction that produces halocarbons is a substitution reaction. And a substitution reaction, essentially the halocarbon substitute or replaces a hydrogen. Okay, so you can say it as being like, oh, I'm not, one person's absent, they get replaced. All right, substitution always happens when the hydrocarbon is saturated. You're dealing with a saturated hydrocarbon this time. All right, and what ends up, I can't predict where the fluorine is going to go. Okay, now it's just to slow down here. Just all you have to remember is if it's saturated, you can't add anything to it. So what's going to happen is you're going to substitute. If it's saturated, it will be a substitution. If it's unsaturated, it will be addition. You can add something to something that's not saturated. You can't add something that's already saturated. All right? So we're going to do replacement. Where's it going to go? There's no rule. Is just one fluorine going to go on or two? There's no rule. So I'm going to give you one possible product here, but I don't know the actual answer. So let's say one of the fluorines goes here, okay? What it did basically is it kicked out a hydrogen. So you'll have another product like HF like that, okay? Or if it kicked out 2 hydrogens, your product would be H2, all right? And so this is a substitution. You get a halocarbon, and you either get like an acid like HF or HCl or HI, or you just get H2. It depends upon whether you kick out 1 hydrogen or more. A little side note that might be important, since I have a little bit of time left in this video, is this addition reaction is used to make something in your house. I figured I would mention it. Hydrogenation is a special type of addition reaction. Okay, you might have heard about hydrogenated vegetable oils. Okay, you might have heard of margarine. Margarine is basically what they do is they take an unsaturated fat that is liquid, and the fats have these double bonds in them. And what they do is they react some fats, which contain lots of these double bonds, and they react it with hydrogen in the presence of a catalyst. Now, unsaturated fats like this, which have double bonds, tend to be liquid at room temperature. However, and that's like corn oil, all vegetable oil. When you fry something, you're using an unsaturated fat, okay? However, if you buy something like margarine, which is supposed to look and taste like butter, though I disagree, I've never liked the stuff, okay? But hey, different strokes for different folks, as they say, okay? Hydrogenation, basically what happens is the hydrogens go into, now they go right into the positions here and here, and they basically turn this thing from being a unsaturated fat into being a saturated fat. And so they essentially add hydrogens around all the double bonds. What that does is it turns it from a liquid to a solid, and then they add a little yellow food coloring, and they call it margarine, and they sell it as a substitute for butter. Hope this helps.